Okay, for the electron configuration problems on slide 35, we have question 1, how many electrons are in each electron orbital, which is also known as the electron configuration, for Ti? Okay, the first thing I need to know is how many electrons does it have. Since it's an atom, I'm looking on the periodic table for titanium. It has 22 protons and thus 22 electrons. So I know I have 22. I'm going to begin. Notice I've got my ordering of all my possible orbitals over here on the side to remind me. So the first two are going in the 1s orbital. The second two are going into the 2s orbital. The next 6 are going into the 2p orbital, so I have a total of 10. So I've used up 10. The next will go into the 3s orbital. So now I'm at 12. I'm followed by the 3p orbital. That can hold 6. And now I'm up to 18. I have 4 left. After that comes the 4. Now here's where, remember, where we don't go to the 3D next, we go to the 4s next. And that's 2. S-type can hold 2, P-types can hold 6. And now I go to the 3, so I'm up to 20 electrons. I go up to the 3D. It can hold 10, but I only have 2 left. I have 20, I've already used 20, so that's just going to get the remaining 2. And this is how, if we were writing an electron configuration, we generally write it to the left and right. The way the question was, it didn't really require that. It says, why isn't the electron of configuration of vanadium? Saying this is wrong, 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. And again, there's a couple ways I can go for this. First, I can look at vanadium on the periodic table. And what I see, it's in the second block of the 4th period in the D block. So I'm expecting, because it's the second one over, the first one should have D1, this should be D2. So I'm expecting this, and it should be 1 less than the period, so I'm expecting this to end in 3D10. And now let's take a quick look at why. Okay, let's look and see that we have the right number of electrons. I should have 23. I'm sorry, it's in the third one. It's in the third block. Should be 3D3. Should be the final configuration. All right, I should have 23 electrons. 2 and 2 is 4 and 6 is 10, and 2 is 12 and 6 is 18. 18 and 5 is 23. It has the right number of electrons, but if we now look at the ordering, it should go 1s, 2s, 2p, 3s, 3p. 1s, 2s, 2p, 3s, 3p. But before the 3D shell is filled, we should be filling the 4s orbital. So this is missing the 4s, 2, and then the remaining 3D3. So this should be the correct. So it's because the 4s orbital is lower in energy than the 3D orbital, and it should be filled first. The next question asks, how many of iodine's electrons are in level 5 orbitals? Okay, and again, I have 2 strategies. I can write the electron configuration and look, or I can find iodine on the periodic table. When I find iodine on the periodic table, I see that in the P block, remember this is the 5s block, this is the 5p block. I have 1, 2 in the s block. I have 1, 2, 3, 4, 5 in the P block. 2 plus 5 is 7, so it's going to be 7 in level 5. The D block for level 5 doesn't occur till period 6, and iodine is in period 5, so there won't be any in the D electrons. Or I can write out the actual full periodic electron configuration. Iodine has 53 electrons, so I'm just going to fill these up. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p, how many do I have left? 2, 4, 6, that's 10, 2, 4, that's 10 again, 20, 36, 38, 48, I have 5 left, 5p5. And now I could see in level 5, I have 2 plus 5 equals 7.